Good morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in this session, I would like to discuss about the design procedure of a Cotter joint. So, the Cotter joint is used to connect the two coaxial rods with the help of Cotter to transmit the power or torque from one place to another place. The Cotter joint mainly consists of shaft, a rod, a socket, and a spigot, and a Cotter, socket collar, and a spigot collar. So the assembled diagram, the cross-sectional view of this Cotter joint shown in this slide. Here, 6 parts or components are there. So one by one, you need to calculate the dimensions of each and every part. For designing, so let's take P is equal to load carried by the rods, and D is the diameter of the rods, D1 outside diameter of the socket, and D2 is the diameter of the spigot, D3 outside diameter of the spigot collar, T1 is the thickness of spigot collar, D4 is the diameter of the socket collar. All these dimensions shown in this slide diagram. So D1, D2, and D3, and D4. Clear? And C and T1. So all these the dimensions shown. So and the C, the thickness of the socket collar, and B, the mean width of the Cotter. So the Cotter dimensions. First need to calculate the diameter of the rod. The first one is first step. And second step is what are the dimensions of socket, the outer diameter and inside diameter. So that is these two, the second step. And third one is outside diameter of the spigot. So what is the outside diameter? And then the Cotter dimensions. What is the width? What is the thickness of the Cotter? And similarly spigot collar. Clear? And then take the distance from the end of the slot to the end of the rod, that is A. And take here shear stress, permissible shear stress, permissible tensile stress, and permissible crushing stress for the Cotter material. These two are for Cotter material and one is for tensile rod. So we will see design procedure. So first consider this rod under tensile stress failure. So when it is subject to tensile load, failure will be occur. So that is which type of failure? That is tensile failure. Under tensile failure, what is the dimensions of the rod? So that is diameter of the rod. So calculate diameter of the rod by using this stress equation. Stress is equal to load upon area. So in this you may calculate D. So diameter of the rod. That is the first step in design of Cotter joint. Second one is failure of spigot in tension across the weakest section. So when it is subjected to tensile load, so what are the dimensions of spigot under tensile failure? So take this the spigot dimensions as T slot dimension width and D2 is the diameter. So apply. Area. The area of the spigot is pi by 400 D2 square and minus the weakest portion. The area is T2 into T multiply with sigma T. So third one is failure of the rod or Cotter in crushing. So use this relation P is equal to T2 into T to sigma C. So in this calculate the sigma C value. So induced stress, induced crushing stress. This value check with given permissible compressive stress, crushing stress. This value always should be less than the given permissible value. Then only your about design is safe. So otherwise, again go back to first or second step and modify your dimensions until satisfy this condition. Next, fourth one, failure of the socket in tension across the slot. Across the slot. So what are the dimensions? D2, D1. So apply this empirical relation. So if by using this equation, you may calculate D1, outer diameter of the socket D1. So next one is Cotter dimensions. When it is subjected to shear, the failure of Cotter under shear, as shown in figure here. So the tau is equal to P by 2 into shear area. So double shear area. So that's why we need to multiply 2 into B into T, width of the Cotter and the thickness of the Cotter. You may calculate B. Next, failure of socket collar under crushing, the socket collar dimensions. So that is D4, the diameter of the socket collar. So given in this figure, D2 and D4. When it is subjected to the crushing, so what is the crushed area? D4 minus D2 multiplied with T. Substitute in this compressive stress empirical relation, you will get D4. Next, seventh one is failure of socket collar under shear stress. So here by using this equation, you may calculate C, the thickness of the socket collar. Load upon the socket collar area, 2 into D4 minus D2 into C. Next, eighth one is failure of spigot under shear. Spigot under shear. So what are the dimensions? D2 already you calculated. So you may calculate A. Next, ninth one is failure of spigot collar under crushing when it is subjected to compressor crushing load. So you may use this relation P by D3 minus D2 to T1. So you may calculate T1 value, spigot collar thickness. The 10th one, the failure of spigot collar under shear. Under shear, again you calculate T1. You can check for here the shear stress, induced shear stress. So finally, the length of the Cotter taken as 4D. The taper in Cotter should not exceed 1 in 24. So sometimes wherever required get a taper, so that time the locking device you must be provided. So this is the procedure of the Cotter joint. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.